Assalamualaikum and welcome to Cambridge Chemistry channel with sarwatahmed. Be sure to like the video and subscribe the channel. It really helps the channel to grow. In this video I will discuss the question of P3 39701 October November 15. This question is about water of crystallization, and this is question number 2 of the paper 3 October November 15. Let's start. Fa4 is an impure sample of hydrated calcium chloride. Hydrated calcium chloride is the salt with water. So like this. On heating, hydrated calcium chloride loses its water of crystallization. This is hydrated salt, and this is anhydrous salt. So when we heat this hydrated salt, water of crystallization is going to evaporate, and hydrated calcium chloride loses its water of crystallization. So this is the reaction. You will determine the purity of Fa4 by measuring the loss in mass that occurs when it is heated. The impurity present in Fa4 is not decomposed on heating. Method. You should read the instructions carefully before starting any practical work and draw a table for your results in the space below. Weigh a crucible and record its mass. Add between 1.80 to 2.00 gram of Fa4 into the crucible. Fa4 is the hydrated calcium chloride. Reweigh the crucible and its contents and record the mass. Place the crucible on the pipe clay triangle and heat gently for 1 minute and then strongly for further 2 minutes. Allow the crucible and its contents to cool. Reweigh the crucible and contents and record the mass. Heat the crucible strongly for further 2 minutes. Allow it to cool. Reweigh the crucible and contents and record the mass. Repeat the heating, cooling and weighing until you are satisfied that all the water of crystallization has been removed. Calculate and record the mass of Fa4 used and the total mass of water lost. So this is the way you have to draw the table. So first, mass of empty crucible grams, so must mention the unit of the quantity. So mass of empty crucible gram is let's suppose that this is 26.405. Mass of crucible plus Fa4 per gram is equal to 28.35. Mass of Fa4 before heating in grams is equal to 1.90. Mass of crucible plus Fa4 after heating in grams, that is 28.15. Mass of crucible plus Fa4 after first reheating, that is 28.08, and mass of crucible plus Fa4 after second reheating, that is 28.07. Mass of Fa4 after heating, that is 1.68, and mass of water lost, that is 0.28. So this mass is 1.628 is we subtracted 28.07 minus the mass of crucible, empty crucible 26.45. It is equal to 1.62. So that is the mass of Fa4 after heating, after second heating, and mass of water lost is 0.28. So this is 1. And this is, we get 0.28, we get 1.90 minus 1.62, that is equal to 0.28 gram. So this is the water lost, and this is the mass of Fa4 after heating, that is the 1.62 and 0.28. Show your working and appropriate significant figures in the final answer to each stage of your calculation. The percentage loss in mass on heating is defined as the loss in mass on heating divided by original mass into 100. So calculate the percentage loss in mass of Fa4 is 0.28. So this is the loss in mass on heating, and divided by 1.90 original mass into 100, that is 14.74 percentage. Calculate the percentage loss in mass when pure hydrated calcium chloride is heated. So this calcium chloride is heated to form two water molecules, so it means 147.1 gram. So we know that 147.1 is the MR of calcium chloride. This is hydrated salt. So 147.1 gram contain 36 gram of water. So what would be the mass if 100 gram of calcium chloride is used? So carrying X, so this is percentage loss in mass is 24.47%. This is how to calculate the percentage loss in mass for 24.47% hypothetically. So this is the exact, this is the exact 100% 24.47 in this experiment, but this is which we have done in previous in the above steps, that loss in mass on heating, that is 0.28, and the original mass, that is 1.90 we were using. So this is actual mass, and this is experimental loss in mass. Use your results 1 and 2 to calculate the percentage purity Fa4 impure calcium chloride, hydrated calcium chloride. 14.74 is the experimental loss in mass. This is experimental loss in mass, and this is theoretical loss in mass, and this is equal to percentage purity. So this is equal to 60.2% is the percentage purity. A student carried out this experiment using 2.60 gram of Fa4. Suggest whether this experiment would give a more accurate result for the percentage purity of Fa4. Explain your answer. Yes, as there will be less percentage error in the weighing mass. So more mass, when we use more mass, then there will be less percentage error, because in the experiment we are using 1.90. so if we use 2.600, then there will be less percentage error in weighing mass. Or you can write down no, because there is more water to be lost, so more spitting and frothing, so percentage error in mass lost will be greater. You can write down this, or you can write down this. Part D. In your calculation, you assume that the impurity in Fa4 does not decompose on heating. State how the percentage purity that you calculated B3 would change if the impurity were to decompose on heating. Explain your answer. There would be the greater loss of mass, therefore percentage purity would increase. So that's why if there are impurities decomposed on heating, then there will be greater loss of mass. Loss of mass would be greater, so therefore percentage purity would increase. So this is all about of this question. Hopefully you would understand this question, that how to solve the water of crystallization of the given compounds in experiment. So if you like this video, please subscribe the channel, and